Hey, now I want us to think about the most beautiful and the most symmetric solid we can imagine. By most symmetric, I mean the object that looks the same no matter what vantage point you elect to look at. Can you guess what that solid is? It's the sphere. You know, when you think of a sphere, you think of sort of the beauty of the symmetry. No matter where I move it, it looks the exact same from every single vantage point. Isn't it amazing? It's sort of perfectly curving the same way in all the different directions. It's amazing. So as beautiful as the sphere is, and as practical it is when we're on the playing field, the point is there's a flaw. And the flaw is it's beautifully curved to make that symmetry. Which means that if we want to compute things about it, for example, its volume, it's going to be a little bit tricky because we don't have flat sides anymore. So the volume of a sphere is going to be something that's going to be a little bit more delicate. And not surprising, since its two-dimensional cousin is the circle, the answers are going to involve the special number pi. All right, so with that as a preamble, let's take a look at how to compute the volume of a solid ball. Well, the volume of a ball is given by the formula 4/3 pi r cubed. That means we take the radius. Now, what's the radius of a sphere? It means the very, very center. You look at the very, very center inside there, and you go out to the outer part, straight out, and that center, that length represents the radius. A little easier if we actually looked at a picture. So let's take a look at a picture. And here you see a picture of my green sphere, and you can see what I mean by the radius. It's the very, very center of the sphere, straight out to the boundary, and that's the radius. So if the radius, for example, were to be 6, as it is in this example, we can now compute the volume of the sphere. The volume is 4/3 pi r cubed. In this case, the r is 6, so we have 6 cubed, which is 216. And so this becomes 288 pi centimeters cubed. It's a volume, so the units are cubed. Neat. All right, let's try another example. Now, this is a funny question. Let's find the diameter of a sphere whose volume is 2,304 pi. Now, how in the world are we going to do this? Well, the first thing I would do, honestly, is draw a picture. You're doing geometry, it's always good to draw a picture. Even if it's a bad picture. In fact, I'm going to deliberately make this picture bad. Just to show you it doesn't matter. It's just to give us something to intellectually hang our hat on. Now, what do we know? We know that the volume is 2,304 pi, but we also know the volume is going to equal 4/3 pi r cubed. And so that's going to equal 2,304 pi. And so now actually I can solve this for r cubed. And so if I multiply everything through by 3, and then divide everything through by 4 pi, then I'd get r cubed by itself, and I'd see that r cubed equals 1,728. And if I take the cube root of both sides, I see that r equals 12. So r equals 12. The radius is 12. That must be the answer. We're done. We can celebrate. Or are we? Let's return back to the question. The question was, find the diameter of the sphere. So we're so close. We're halfway there, in fact, because the diameter, of course, is twice the radius. So the diameter, which is what we want, is actually going to be 24. And what are the units? Are the units inches cubed? No. Diameter is a length, so the units are just inches. And that's the true answer right there. So always make sure we answer the question that we're after. And you can see how we use the volume formula to do that. How about if we don't look at a whole sphere? What if we look at half a sphere, also known as a hemisphere? So that's exactly half of a sphere. Here I have a hemisphere that has a radius of 5 meters, and the question is, what's the volume of it? Well, I haven't given you a formula for the volume of it, but I think we can figure it out, because since a hemisphere is half of the whole sphere, we just find the volume of the whole sphere, take the answer, and divide by 2. So not a big deal at all. Let's try to figure it out. So the volume will be 1/2 of the volume of the whole sphere, which is 4/3 pi r cubed. In this case, the r is 5, so 5 cubed is 125. And so we can simplify this a little bit because, in fact, this 4 divided by 2 just becomes a 2 on top, and 2 times 125 is 250 divided by 3 pi. And so my units are meters cubed, its volume, and there you have it. So notice that we took half of the volume of the whole thing. So you can see how we can use the volume of the sphere formula to actually compute lots of volumes, not just for spheres, but also even for hemispheres. Cool. Okay, so we've thought about the volume of a sphere, and we saw that we can actually use the formula to compute the volume of a sphere just knowing the radius. But now let's take a look at another aspect of the sphere, namely the actual surface that makes the sphere a sphere. So if you take a look at this, you can see this polka dotted sphere. You can see that the polka dots are lying on the surface of the sphere. Well, if we were somehow able to sort of cut this all open and spread it out on the table, we would see that in this case, I guess it's made out of rubber, that rubber would have a certain amount of area. So we can actually figure out the area that's on the outside of the sphere, which is known as the surface area. Now again, it's so curved in such a beautiful way, but that curvedness makes it difficult to actually produce the surface area formula. And the formula, of course, does involve pi, since somehow there's circles involved. The surface area for a sphere turns out to be given by 4 pi r squared. Notice that, again, volume is always in terms of something cubed, and here we're seeing that area is something squared. So sort of everything is consistent in the world, but the formula is, in particular, 4 pi r squared. All right, let's see the formula in action now that we understand what it means. Okay, so the first question I want us to ponder together is to compute the surface area of a sphere with diameter 5. Okay, well, let's just charge right ahead. I'm going to do this and make a mistake. See if you can see what mistake I made. Okay? So this is going to be wrong. Surface area. Here we go. There's the formula. 4 pi r squared. And units squared. What do you think? Do you see the problem with this? Well, the problem with this is I was being a little bit cavalier. I saw this 5 and thought it was a radius. But if I read the question carefully, I see it's actually a diameter. This is actually wrong. So let's see if we can do it correctly and more carefully. The surface area is going to equal 4 times pi. And now I've got to put the radius squared. What's the radius? Well, if the diameter is 5, the radius will be half of 5, which is going to be 5 divided by 2 squared. And what does that work out to be? Well, that's 4 pi times 25 on top and 4 in the denominator. And this can actually be simplified down to just 25 pi, because the 4's can actually simplify. And what are my units? Well, it's area, after all. And so I see r squared, so I see feet squared. So that's the correct answer. If you sort of got fooled into looking at the wrong answer, that's just a little sign. It's a great mistake to make. Don't feel bad about it. But just make sure that you read the question carefully and make sure you see diameter. And remember, here r is radius. Great mistake. Okay, let's take a look at another example. Let's find the volume of a sphere that has surface area equal to 196 pi meters squared. Now, what's going on here? Here I'm asked to find the volume. Let me remind you what the volume formula looks like. It looks like that. Well, I'm asked to find the volume, but I don't know the radius. I just know the surface area. Well, that's okay. I can use the surface area formula in order to figure out what the radius must be. So there's an intermediate step to this question. I know that 4 pi r squared represents the surface area, which in this case is 196 pi. So if I divide both sides by 4 pi, I see that r squared equals 49. And if r squared equals 49, then r equals plus or minus the square root of 49, or plus or minus 7. But wait, in this context, r is representing the radius, which means that it has to be positive. So in this context, I know that r has to be 7. Okay, great. Now, if r is 7, I can now plug it into the volume formula and see that the volume is going to be 4/3 pi times 7 cubed, which works out to be 1,372 over 3 pi. And what are my units? My units are meters, but its volume, meters cubed. And so there you have it. So here was a question which first forced me to use surface area in order to find the radius in order to compute the volume. Neat. How about this question? Let's find the surface area of a sphere with a great circle that has an area of 36 pi inches squared. Now, what's a great circle? You're saying, oh, a great circle, that's like a really good one. Well, no, actually, a great circle is a mathematical term that actually has some meaning. Let's take a look at a sphere, and I will show you what a great circle is. So if here's a sphere, in fact, what I drew in there is a great circle. It's the largest circle that can be drawn along the exterior of the sphere. In some sense, it's the place where the circle has the biggest waist. Another way of thinking about it, if you thought of a globe, is it's the equator. So, in fact, that's what it means to be a great circle. And I want to find the surface area. Well, I've got the formula. But all I know is that the area of the great circle is 36 pi. Well, what does that mean? Well, if I take a look at a top view, then here's the great circle. I don't know what the radius is, but its area is 36 pi. Well, we know the area is pi r squared, and that equals 36 pi. If I divide both sides by pi, I see that r squared has to equal 36, which means r has to be either plus or minus 6. But of course, we know r is positive, so r must be 6. So that allows me to figure out that r is 6. So this sphere has radius 6. That's not the answer. That's the key to unlock the answer, because now I can find the surface area. It's 4 times pi times 6 squared, which is 36. And so I see 144 pi, and my units are inches squared. And so you can see that we can use lots of different pieces of information, sew them together, and actually answer lots of interesting, fun questions involving spheres.